Hello everyone, welcome back to my channel. In this session, I will be discussing about the efferent fibers of the white matter of cerebellum. So before you watch the session, please see the previous 4 sessions where I have discussed about the external features, the nuclei and the classification of the white matter of cerebellum. So we will come to the discussion of the efferent fibers of the cerebellum. So we know that the main fibers which are coming out of the cerebellum comes through the axons of the Purkinje cells. So it is the axons of the Purkinje cells which are the main source of efferent impulses. And they will be actually influencing the different parts of the central nervous system like the red nucleus, the thalamus, vestibular system and the reticular formation. So these are the 4 parts of the central nervous system which are actually influenced through the efferent fibers by the cerebellum. Now coming to the axons of the Purkinje cells. They have 2 options. One, the Purkinje cells which are confined to the flocculonodular lobe and the vermis of the cerebellar cortex will be directly exiting and they will be relying to the lateral vestibular nucleus. So that means they are not actually synapsing with the intracerebellar nucleus. That is the main point. They are having a direct exit. That is, the axons of the Purkinje cells are directly exiting from the cerebellum and they will be reaching the lateral vestibular nucleus. Whereas the other fibers from the different parts of the cerebellar cortex, the axons from the different parts of the cerebellar cortex, they will be relying in the intracerebellar nucleus. So which are the intracerebellar nuclei you know about? They are the dentate, globose, emboliformis and the vestigial nucleus. So out of these 4, the axons which are relying in the dentate, globose and emboliformis nucleus, they will be actually passing through the superior cerebellar peduncle, whereas the fibers which are relying in the vestigial nucleus will be coming out or making its exit through the inferior cerebellar peduncle. So ultimately, Purkinje cell axons are the chief source of axons for the efferent impulses compared to all the rest of the nuclei in the cerebellar cortex. And they can have 2 options. One, they can directly exit from the cerebellum, or they can rely in the intracerebellar nuclei and from there the neurons will be exiting through the different cerebellar peduncles. So these are the 2 options. Now we have already discussed about the climbing fibers and the mossy fibers. So this is actually an intrinsic neuronal circuitry of the cerebellum. So we have seen the climbing fibers and mossy fibers in detail in the previous session. So one climbing fiber will be actually having an excitatory response on one Purkinje cell and one mossy fiber will be having an excitatory response on thousands of Purkinje cells. So this is actually a direct sort of stimulation, whereas in mossy it is not direct. It is actually stimulating the Purkinje cell through the granule cell. So out of the different types of nuclei or the cell bodies in the cerebellar cortex like the granule cell, the basket cell, the stellate cell, the Golgi cell. So out of all these, only the granule cells are excitatory in response, whereas all the rest of the nuclei in the cerebellar cortex are having an inhibitory sort of response, but only the granule cells are excitatory in function. That is very, very important. So the climbing fibers, they excite the Purkinje cell directly and the mossy fibers, they excite the Purkinje cells indirectly through the granule cell. So that is very important. And the axons of the granule cell will be there in 2 to 3 millimeter area of the cerebellar cortex, and in this 2 to 3 millimeter area you have roughly 500 Purkinje cells situated. So that is the proportion. One granule cell can actually influence around 500 Purkinje cells. So one mossy fiber, one granule cell, 500 Purkinje cells, whereas one climbing fiber, one Purkinje cell. So that is the proportion. Apart from this, we have other options. Like the collaterals from the climbing fiber will be actually having an excitatory response on the intracerebellar nuclei. Apart from that, it will be having an excitatory response on the stellate and basket cells of the cerebellar cortex. But we know only the granule cells are excitatory. So what about the stellate and basket? They are inhibitory. So when these are stimulated, they will actually go and inhibit the Purkinje cells. So this is actually known as the feed-forward inhibition. The climbing fibers, excitatory on stellate and basket, but on stimulating this will actually inhibit the Purkinje. So climbing, pushing the stellate and basket, pushing the Purkinje, but this is actually an inhibitory response. So this is known as feed-forward inhibition. But when you look at the mossy fibers, the collaterals to the intracerebellar nucleus, just like the climbing, they are excitatory. The branches to the Golgi, the synaptic terminals to the Golgi, they are again excitatory, because the climbing and mossy are mainly excitatory. Whichever synapse they make, it will end in an excitatory response. That is first and foremost. But here what happens? When these Golgi are stimulated, they will actually inhibit, because Golgi cells are inhibitory. Only the granule cells are excitatory, isn't it? So the Golgi will inhibit the granule. So what type of inhibition is happening here? This is actually decreasing the excitatory response of the granule. So that is actually resulting in the inhibition of the Purkinje cell. So this type is known as feedback inhibition. Here it is feed forward. Why? Because climbing, excitatory on stellate and basket. When it is excited, it is actually having an inhibitory response on Purkinje. So the action of stellate and basket is to inhibit the Purkinje, and so that is known as a feed forward. But here the action of granule on Purkinje is actually stimulatory, but that is actually inhibited by the response from the Golgi. So that is actually a feedback inhibition. On stimulation of the granule, it is not going to inhibit the Purkinje, but it's not going to stimulate the Purkinje, which is the actual role of granule, but it is inhibiting the Purkinje. So it is actually a feedback inhibition. So these two you should be knowing: feed forward inhibition and feedback inhibition. I will tell once more. Feed forward inhibition means climbing, excitatory on stellate and basket cell. On the impulse at the stellate and basket cell, it will inhibit the Purkinje, which is the main action of stellate and basket cell, because they are mainly inhibitory. But here the mossy fibers, excitatory on Golgi, it is actually inhibitory on granule. So inhibitory on granule means the excitation is inhibited. The normal action of the granule is to excite the Purkinje, but because of this inhibition, so it is pushing the granule not to excite but to inhibit. It's the normal action of the granule is not to inhibit, it is excite. So it is the reverse what is happening because of the inhibition by the Golgi cell. So it is known as a feedback inhibition. Now, apart from having a positive response on Purkinje, the granule cells also have a positive excitatory sort of response on basket cells and stellate cells, because we have already mentioned that only the granule cells are excitatory in function, whereas all the rest of the cells in the cerebellar cortex, they are inhibitory in response. So what will happen if basket and stellate cells are stimulated? They will have an inhibitory response on the Purkinje cell. So the granule cells is actually influencing Purkinje cell in two ways. One is by direct stimulation, and one is by an inhibitory response through the basket and stellate. Okay, so this mode of controlling the response from the Purkinje is known as neuronal sharpening method. That is, the granule cell directly they are excitatory to the Purkinje. They are also excitatory to the basket and stellate cell, and through them they are actually having an inhibitory response on the Purkinje. So this is actually a mode of neuronal sharpening. And now what happens to the impulses from the Purkinje? They are always inhibitory. as we have already mentioned, because only the granule cells are excitatory. So the responses from the Purkinje through the climbing and through the MOSI will be having an inhibitory response on the intracerebellar nuclei, and this will be carried to the motor areas of the cerebral cortex brainstem. And this is how the motor activities are coordinated. And intracerebellar nuclei are known as the pacemakers, because apart from being influenced by the Purkinje fibers, they are said to have an intrinsic excitability. Within the nucleus, they have a sort of intrinsic excitability mechanism. Because of this property, the intracerebellar nuclei are considered as the pacemakers of the cerebellum. So to summarize, we know that the efferent fibers, they are actually carried by the axons of the Purkinje cells. They are actually considered as the chief efferent source of impulses, and from there they can directly make its exit to the lateral vestibular nucleus or through the intracerebellar nucleus, and the peduncles being the superior and inferior cerebellar peduncles. And we have the exit from the Purkinje axons, and the mechanism, this is actually the intracerebellar circuitry. So we have seen the feed forward inhibition and feedback inhibition. Feed forward inhibition means it is the response of the stellate and basket to inhibit the Purkinje, whereas feedback inhibition means the granule cell is usually excitatory to Purkinje, but because of the influence of Golgi, it is inhibitory, and that is known as feedback inhibition. And the granule directly influencing the Purkinje and indirectly through the basket and stellate cell being inhibitory. This sort of mechanism is known as neuronal sharpening. And the Purkinje axons, they are actually inhibitory just like any other nuclei apart from the granule cell, and they will be influencing the intracerebellar nucleus, and from the intracerebellar nucleus the information will be carried to the motor areas of the cerebral cortex and brainstem, and this is how the smooth coordination of the motor activity is made. And the intracerebellar nuclei are considered as a pacemakers. Why? Because apart from being influenced by the other nuclei, they are said to have an intrinsic excitability property, and because of that they are considered as the pacemakers. So hope this is a very short video regarding the efferent fibers of cerebellum, but it's very easy if you understand. Please leave your comments in the comment section so that I'll be doing more and more sessions. Thanks for watching.